Hey guys, hope you all had a good week. You might remember last week we did a breakdown of a Dell laptop. We went through the schematic on it and just worked out on the board where the 19 volts went and just tried to get a feel for how it actually works. Well, this week I have one of these. It's a Satellite Pro A50-C-204. It's a 15.6 inch i5 laptop, quite heavy at 2.1 kgs. But any of the ones that had a DVD drive were, a little bit heavier, a little bit bigger anyway. So what I'm going to do with this is do a similar breakdown to what we did with the Dell last week. This is again fully functional, so there is no fault with this laptop. So what I'm going to do is I'm going to take the 19 volts from where it enters the laptop and see if we can work out what's going on. So let's get straight to it. So this is our motherboard removed and on the table, and it's actually quite easy to take these out, so it was a quick enough process to do, certainly not like the older ones. So where we're going to start here is if we look at the top left, you can see up here we have our DC jack, and there's only two wires on the Toshiba. There is a red and a black. So I'm going to zoom in on that section there. Let me zoom in and get to 100%. So you can even see the wires below, so there's a slight bit of black there, and you can see the red wire right here. So immediately what I can see is that this is our ground plane right here, connected to our black wire, and here is our red wire here, so that's connecting to our positive, and we're going to start right here. So once again, with all these measurements, we're putting our multimeter in volts DC. On my multimeter that looks like this. So we volts DC in the 20 volt range, and I place my black probe to ground, and when I place my red probe right here, I get 19 volts. So our 19 volts on this laptop is getting from our power adapter through our cable onto the motherboard, and it's reaching this point right here. So we have 19.4 volts, just to be precise, at this point here. So I'm going to leave my black probe on ground and measure here. And when I measure at this point here, I also get 19.4 volts. This is just an inductor. So next in line is the main fuse. So once again, this fuse will be shorted if there's anything wrong with the laptop. It's a safety mechanism. I know this laptop is working, so we should be seeing 19.4 volts here also. So when I place my probe right here, we also have 19.4 volts. So we've established that our 19.4 volts comes through our cable here, through this inductor, through this fuse, and onto this part right here. But there is no indication where these vias go on the other side of the board, and I don't have a data sheet. But what I needed to do was find where on the board there was a 19.4 volts. So I searched around all the components, measuring around them all. I found a lot of them that had 19.11 volts, which I think was the main power rail. I found that on many of the capacitors on the secondary circuits, like I found it here for example. I found it on this capacitor right here also. But that was 19.1 volts. What I should be seeing at the next point, the point that's continuous with this, is 19.4, and the only place I found 19.4 volts was right here. Now this component looks a little unusual. It's got 4 pins on it, so it's not like a regular 8-pin MOSFETs that we would usually see at this part of the circuit, and it has a line on it here, so I think it's just a diode. Unusually, I couldn't find out by simply searching, 10Q83 or 70150. I couldn't find out exactly what it was, but look, we don't need to know the exact workings of these sometimes. As long as our 19 volts is getting through it, then it's not faulty. I think it is just a dual diode. Maybe somebody in the comments could put down. But what I see is, when I measure the other side of that, I find that there's 19.1 volts right here. So there's a 0.3 volt drop through this diode right here. But the fact that it's 19.4 volts and not 19.1 helps me to work out that this is the next component after the fuse. Okay, so 19.4 right here, 19.4 here, and then after the voltage drop through the diode, it then becomes 19.1 volt. This is just to prevent a reverse connection. It allows the current to only flow one way. So that's our 19.1 volts getting right here. So from this point, not sure what this was for, it's just an empty pad right here, but there's no component as you can see at this point, but there are a number of vias once again right here. So just looking at that pattern, we've got 1, 2, 3, 4, 5, 6, 7 on this side and 2 right here. So I'm going to follow this through to the other side of the board. So just to be comprehensive, I have marked the red line where our 19 volts goes through our diode and onto these vias right here. Now we're going to flip the board. So we followed through the board and I can find those vias right there, 1, 2, 3, 4, 5, 6, 7 and 2. So that matches the pattern on either side of the board. And when I measure right here, I find that there's 19.1 volts at this point also. So we know it's coming through to right here. Now this is a 7426 MOSFET. Apologies about the quality of the images on this one, they're not as good as they usually are, but that is a 7426. So when I check out the datasheet for that, what I get is this right here, Aeon 7426 30 volt N channel MOSFET. Okay, so this is similar to the Dell that we looked at last week. So the way these work is you have your 4 drain pins right here, your gate pin and your source pin, source pins. So when the voltage is high to this gate pin, the voltage passes from drain to source in this configuration right here. If the gate is low, then it doesn't carry the 19 volts from here to here. So let's take a look at that on our actual board. So it's really just a switch. So if you take that, here we go right here. So these are our 4 pins that are together, so I know that these are our 4 drain pins. These 3 pins are together as well, so these are 3 source pins, and this is the gate pin, which controls whether the MOSFET is on or off. So we have our 19.1 volts here. So I measure the gate, and when I find 24 volts on the gate pin, I know that that's high and the MOSFET should be switching on. And sure enough, when I measure right here, I find that there's 19.1 volts here. The next component in line is our current sense resistor right here. Now these very rarely fail, but the purpose of this is so that the power management chip can work out by calculating the voltage drop on this, what the current going into the machine is, and it can shut it down if it sees that the current is too much. But I just measure on the other side right here and I find that there's 19.1 volts right here also. So I'm going to mark that with my usual red line right here. So this is where we are. We've got 19.1 volts right here. And I'm thinking at this point that, you know, after the current sense resistor, this should be our main 19 volt rail. However, I see another 7426 MOSFET right here. So this is a little confusing because on the other Dell and on many laptops you have 2 MOSFETs, then the current sense resistor. Here we have our N channel MOSFET, current sense resistor, and this then is another N channel MOSFET, and it's the exact same type. However, when I measured on the other side of this, I found that there's 16 volts right here. So that is not part of our main 19 volts power rail. I think this is the high side MOSFET for a high side, low side MOSFET configuration. And because the voltage is around 16 volts, I actually had the battery plugged in when I measured that. So I think this is part of the battery charging circuit. So there is one other component here which I think is an inductor. And then I think this is our main 19 volt rail right here, which goes out to the rest of the board. So we've now found where our main 19 volt power rail is. It's essentially at that inductor and current sense resistor on the other side of the board. I've flipped back over to the front, and what I'm going to do now is measure to find that main 19.1 volt power rail across the board. So I went around the board and I took measurements, and I could find that 19.1 volt power rail all around the place, as you would expect, because the 19.1 volts is the input for all of the other secondary circuits, and then those circuits break that 19.1 volt down to 1.2 for the RAM, 3.3 for a power button, BIOS, SIO chip, and other smaller voltages. So here, for example, is our 19.1 volts as our input to this IC here. Here's our output with our lower voltage, our current sense resistor. There's a 19.1 volt right here as the input to this chip right here. Similarly, down here we have another couple of circuits. So we have our 19 volts right here, and this is our high side, low side MOSFET configuration with our inductor here, current sense resistor here to measure the current through this part of the circuit. And I'm going to take the example of this one right here. Okay, so if I measure 19.1 volts here, which is our main power rail again. So this chip right here is a TPS 51363. If we check that chip out, what you can see is that this is a 22 volt input, 8 amp or 10 amp converter with integrated FET. So this has an input of 3 to 22 volts. So our input is 19.1 volts, and then the output is 0.6 or 2 volts. So this is probably producing like 0.8 volts to 1 volt for the processor, or maybe 1.8 for a chipset or something like that. But we can measure the 19 volts at a number of different points around the board. And the next part I'm coming on to right here is this component down here. Apologies again for the quality of the photos. These ones just didn't come out right and I didn't have an opportunity to retake. But I measure 19.1 volts down here also, and on this capacitor right here and on this capacitor right here. And I also measured it on the input to this chip right here. So in the process of my searching around the board and verifying our 19 volt main power rail, I found this chip right here. Now I recognize this from the last time, the 1285B, because this is the chip that provides our VREG3 and our VREG5. So these are our 3 volt always on and our 5 volt always on. Now this is the one that's used for the power button. So what I did to verify this is working is we look at the V-in pin. Now this is on its side right here. So what I'm going to do here is I'm going to flip my image of that chip. So as you can see, 1285B, 1285B, and these, the pin out now corresponds. So right here, pin 12 is where the V-in is. So I place my probe to here, which is where it comes in, and I measure 19.1 volts there. So the next thing to measure then is, with the laptop powered off, obviously these two will still be on. The other 3.3 and 5 volts that are generated by pulse width modulation are not on while the laptop is off, but these two are always on. The VREG3 is always should always be 3.3 volts, and the 5 volts should always be 5 volts as well. So I place my probe right here to this via right here, and I measure 3.3 volts right here. And on our VREG5 pin 13 here, the safest place to measure is right here. This comes out from this point here. I measure it here, and our 5 volts is there as well. So that tells me that our 3.3 volts is also online. And the next question is, with our 3.3 volts online, is that on my power button, and is my power button working? So I searched around the board and I found that this is our power connector right here. So I measured the voltages on each of those pins, and this is what they measured as. So we've ground 3.3, 3.3 and 3.3. So when I got my power button and plugged it into this, what I found was that this 3.3 volt was grounded when you pressed the power button. So it was essentially just connecting this pin to ground it. And that signal is sent back to our startup chip on the other side of the board to tell the laptop to switch on, or if you hold them, it tells it to switch it off. The startup chip is this chip right here. Just one further observation on our Super I/O chip right here as well. I found that the 3.3 volts or 3.2 volts is on this capacitor right here as well, so we know that this is getting power. So usually when the laptop is powered off, we need to measure and make sure that there's 3.3 volts on the power button and somewhere around this as well, just to make sure that it's getting input power. On the BIOS chip, it seems that on this model, when I measured pin 8 with the laptop switched off, that's pin 8 would be 1, 2, 3, 4, 5, 6, 7 and 8. There is 0.3 volts on this while the laptop is powered off. It's only when you power it on that you find that there's 3.3 volts on this right here. For the last step of my tour of this little Toshiba board, I'm just going to take down the values again. I did this the last time in the video. It just might be useful in the future just to have an indication as to what these values should be on a working laptop. So this inductor right here has a diode value of 0.489, a resistance value of 280 kilo ohms, and this is obviously on the battery circuit. So when the laptop was switched off, it was still charging, at 16 volts, and when I switched it on, it was charging at 16 volts as well. I took those measurements obviously with the battery out, so just to take note of that as well. The value down here then, this inductor right here was 0.03 in diode mode, 90 ohms. When it was off, I measured 0 volts, and when it was on, it was 1.34 volts. Now, here's the question for you. That is beside the memory. However, on the previous laptop, we only measured 1.2 volts. So, what is the reason why it's 1.3 volts? And I'm going to give you a hint right here. Let's see. Put the answer in the comments below. This next inductor right here, with a diode measurement of 0.005, resistance of 8 ohms. It was 0 volts when it was off and 0 volts when it was on. The next inductor right down here measured 0.005 in diode mode. 10 ohms resistance, was 0 volts when off and 0.9 volts when on. This inductor right here was 0.015 in diode mode, 22 ohms. When the laptop was off, it was 0 volts, and when it was on, it was 0.95 volts. This inductor right here, 0.066 volts in diode mode, 100 ohms resistance, 0 volts when off, and 1 volt when on. You might remember when I did this the last time, I looked through which circuits they were because I had the datasheet, but as I've said already, I don't have a datasheet from this, so we're just flying blind. On this inductor here, it was 0.228 volts in diode mode, resistance of 1.8 kilo ohms. When it was off, it was 0 volts, and when it was on, it was 1.8 volts. So I presume that 1.8 volts is for the chipset. And then we have these two big inductors down here. So in diode mode, this one measured 0.393 volts. Resistance of 100 kilo ohms. When it was off, it was 0, and when it was on, it was 5 volts. So this is the 5 volts. It's not the 5 volts always on. This is the 5 volt for the USB when it's powered on. And lastly, this measured diode mode was 0.298. Resistance was 8 kilo ohms. When it was off, it was 0 volts, and when it was on, it was 3.3 volts. So this is the 3.3 volts. Obviously, that powers the BIOS when it's powered on. Well, that's all I got for you this week, guys. Hopefully you enjoyed me on that quick tour of how our Toshiba laptop motherboard works. These are a little bit of a puzzle because you have no data sheet, no schematic with these, and they can take jumps, you know, out of the blue, like comes into here and then jumps over to here without any indication. So you do have to sort of use your intuition to find out where they're going. But I found that experience useful anyway. We get a lot of Toshibas in, so I think it will be useful in the future for me to have, you know, this video to reference back to for the values, and just, you know, see which parts of the circuit are in which locations on the motherboard. I did this last week because I didn't really have any content. I just like hinge fixes and stuff like that. Nothing entertaining, nothing worth broadcasting. But a good few people seemed to like the way I did it last week, so I might do a few more of these things, just essentially troubleshooting and taking notes, and that's what I'm going to call them. So I'm going to post this one now, and if you have any comments, you can leave them for me below. Is there anything else that I should be taking note of for future reference? Is a good question, actually, because I'm taking diode mode, resistance mode, power, what the value of the component should be when it's on, when it's off. Any other suggestions as to what I should be taking note of? If you can think of anything, stick it down below. And I will be back next week. Have a good week.